Okay, we'll try to finish up chapter 1 here. So the definition, the difference quotient of f is f equals f of x plus h minus f of x all over h, and h cannot be 0. The difference quotient is often used in calculus to calculate rates of change. And so in the last example, that's the one up here, if x is 1 and h is 3, we plug that into the difference quotient. X is 1 and h is 3. It looks like we have f of 4 minus f of 1 all over 3. Okay, f of 4 minus f of 1 all over 3. Huh. Okay. Well, that's 2.5. So you would be finding the rate of change in the 3-hour time span starting at 1 p.m. in that particular problem. So the difference quotient is a very important formula in calculus, and you use it quite a bit. Early on, you use it quite a bit. So I really just want to get us some practice calculating a difference quotient by using the formula. Not really going beyond that, though, because the main idea is for you to calculate a curve that has a slope of anything, and it could be turning and stuff. And if you were to draw a line from the first point to the second point and find that line, the slope of the line would be, some number, and that's really what the difference quotient tells us. Okay, so for example, if we had a line, f of x equals 4x plus 7. F of x plus h minus f of x all over h. Well, f of x plus h is, here's f of x. So f of x plus h means I'd plug in x plus h in for x. Okay, so I've done that. And then I subtract f of x. And this is all over h. Now, it will usually happen where you'll have some terms canceling out. Here, anything not involving h cancels. So here's 4x minus 4x, 7 minus 7, and that leaves us with 4h over h, which is 4. The difference quotient for a linear function is always equal to the slope. Well, the slope of this line would be 4. So the difference quotient is also 4. Anytime you have a line, the difference quotient is the slope of the line. Okay, so what if we don't have a line? What if we have some curve, f of x equal 2x squared plus 3, okay? And we want to calculate f of x plus h minus f of x all over h. Well, f of x plus h, here's f of x. F of x plus h means that I'd plug in x plus h where I see x. And so I've done that. And then I subtract f of x. Okay, I've done that. And this is all over h. Now, just like before, we're going to have some things canceling out. Anything not involving h is going to cancel out in this problem. Here's 2x squared minus 2x squared, 3 minus 3, those are gone. And that leaves us with 4xh plus 2h squared all over h. H is in common to those terms, to the term that's in the denominator. So I can factor that out and then cancel it with what's in the denominator. And that's going to leave me with 4x plus 2h. Okay, 4x plus 2h. In general, you're always going to get something involving, you know, x or nh, and that's if you don't have a line. Okay, now this would be a curve, and I'd be, you know, drawing a line starting at you know, anywhere and ending at anywhere. Now, wherever I draw that line, I won't be drawing a line on top of a line. Okay, because this is a curve. This is 2x squared plus 3. And the x squared means that I don't have a line. Okay? So this is as far as I can go, 4x plus 2h. The average rate of change of a function from x to x plus h is the same as the difference quotient. Okay, so if I go back to the problem where I was computing an average rate of change, here's the formula for that: f of b minus f of a over b minus a. And I end up getting 58 minus 50.5 divided by 3. Now that would be the same thing that I would get if I were to compute f of x plus h minus f of x over h if x is 1 and h is 3. Okay, so check it out. If x is 1 and h is 3, I get f of 4, and then minus f of 1 all over 3. F of 4 minus f of 1 all over 3. Okay, so the average rate of change of a function from x to x plus h is the same as the difference quotient. There's a problem on page 68 that I wanted to do here. Problem 112, and here's that problem, by the way. So I want to answer the following questions about this graph, and give the answers on the space provided. Part A, find the zeros of f. Okay, the zeros are the same thing as an x-intercept. So it looks like I have an x-intercept right here at -3, right here at +3. Okay, so that would be the zeros of the function as well. Part B, give any x and y intercepts on the graph of f. Okay, the x-intercepts, like I guess I've already said those. Those are -3, 0, and 3, 0. An x-intercept and a 0 are the same thing. Now, y-intercept is where you cross the y-axis. So that point would be at 0, -2. Part C, identify where f is negative or positive. Well, let's see here. So you're going to be negative if the curve is below the x-axis, and you're going to be positive if the curve is above the x-axis. So where's the curve above the x-axis, and where's it below the x-axis is the question. Well, where's it above the x-axis? From -4 to 3, you're above the x-axis, and from 3 to 4. So -4 to 3, and from 3 to 4, we are positive, and everywhere else we're negative. Negative meaning that the values of y are going to be some negative number. Okay, so like here's when x is 0, y is -2. And anywhere that's between x equals 3 and x equals -3, you're going to have a negative negative value of f. Okay, part D. Identify where f is increasing or decreasing. Okay, well, increasing means that the slope of the graph is positive, and decreasing means that the slope of the graph is negative. It looks like anywhere from 0 to 4, I'm increasing on that part of the graph. So here, if I draw a tangent line, the slope is some positive number. And I'm going to be decreasing from negative 4 to 0. So if I draw a tangent line there, the slope is a negative number. And so part E is the average rate of change of f from x equal 4 to x equal negative 4 positive, negative, or 0? Okay, well, average rate of change from negative 4 to positive 4. I've drawn a line lightly here. I don't know if you can see that. And the slope of that line would be a negative slope. Okay, a positive line, or positive slope line is slanted like this, and a negative slope is slanted the other way. So negative would be the answer. Okay, the homework is on page 64. Here's the problems that I'd like you to do in section 1.4.